welcome back to Calculus. We are doing section 3.7 today, implicit differentiation. So implicit differentiation is a little bit different. It's going to use the chain rule, but let's consider an example first, and then we'll look at how we're going to deal with this. So let's look at the example where we have y squared is equal to x. This is definitely not a function in the normal. I guess we could say x is a function of y, but that's kind of backwards. So this is not, what we would normally consider to be a function. It's just not the way we would normally do this. So what we're going to do to try and get a derivative out of this, because we do have the square here on the y, is we're going to treat y as a function of x. So y is its own little function, and use the chain rule. And so we'll see what that looks like as we do the example here on the next board. All right, so let's go ahead and take this derivative. We want to find dy dx for y squared is equal to x. So this is a pretty straightforward example, so hopefully it's a good one to kind of get started with this. I'm going to start by taking the derivative of both sides. On the right-hand side, the derivative with respect to x is just 1, right? We know that derivative really well. On the left side, that's where the fun is going to happen because we have a y there. So we know how to take the derivative of something squared, so we go ahead and do that. We get 2y, but then because y, it was on the last board, because y is a function of x, this is where that chain rule comes in. Remember, the chain rule says you have a little function and inside of a bigger function. So my bigger function here is that squared function, but y is its own little piece, its own function. So we have to take its derivative, which is good because we actually want dy dx. So I get 2y from dropping the exponent down, but I can't forget then to take the derivative of y. And so that's my chain rule. And then if we want the dy dx by itself, we just divide both sides by 2y, and so dy dx is 1 over 2y. There it is. That wasn't so bad. We can find the slope of the tangent for this one at the point 4, -2. So we're just evaluating our derivative of y with respect to x at y equals -2. Notice x doesn't matter here because there aren't any x's. If we did have x's, we would just use them both. So I plug in the -2 for y, and I get a slope of -1/4. Okay, so continuing on, just some basic steps for implicit differentiation, and then I have an example, and we'll do more here in just short order. So number one, take the derivatives of both sides with respect to x. Once you do that, collect all of your dy dx's on one side. Basically, we're going to solve for dy dx. And so some of them will be easier than others. This next example isn't too bad. I have x squared plus y squared is equal to 100. Let's get dy dx by implicit differentiation. So I take the derivative with respect to x on both sides. The derivative of 100 is just 0 because it's a constant. On the left side, the derivative we have a sum, so that's nice. We can treat the two parts separately because it's a sum. The derivative of x squared is 2x, but the derivative with respect to x of y squared is 2y, and again, we're treating y as a function, so we get then the dy dx out of that chain rule. So anytime you take a derivative of something with y, you're going to get a dy dx. All right. So now I'm solving for dy dx. I subtract the 2x. I divide by 2y, which makes the 2's go away. And so we just get dy dx is -x over y. All right, so this one is a monster example. Feel free, I'll get out of the way in a second. Feel free to pause it, write everything down, and then listen to me talk about it because this one's big and ugly and a mess. We want to find dy dx if y cubed is equal to x cubed plus the cosine of xy. Now, one thing that's going to make this really fun is that we have y's in two different places. One of them is stuck inside of a cosine as part of a product rule. So there is so much going on here with this problem. So try and follow along. All right, so here is everything I have on this board. I start by taking the derivative of both sides. The derivative with respect to x of y cubed is 3y squared, and because there's a y, I'm going to have a dy dx. On the other side, it's equal to, well, the derivative of x cubed is just 3x squared. That part's nice. But then we get to this cosine. And the cosine is going to really cause some problems because we do have this product on the inside. It's not just cosine x. In fact, it'd even be easier if it was just cosine y, but it's not. So I took this over here and called u the inside of this cosine. Okay, I'm going to do a chain rule on this cosine. So the derivative of u is the derivative of x times y. Right, we have a product rule here. So we take the derivative of the first thing and get 1 times the second thing plus the first thing times the derivative of the second. The derivative of the y is just 1, but we get a dy dx. So you can see I brought all that back here. Derivative of cosine is minus sine, so I get minus sine of xy, and then times my du, which I did clean up just a little bit, and it's just y plus x times dy dx. That was exciting. Feel free to have your head explode now. Because we're not even close to being done. I need dy dx all by itself. I still have it in 2 places. So that's not a good thing. To fix this, first I need to get this one out of the parentheses. So the next step was to expand the sine yx times the parentheses. So I did that. The left side stayed the same, 3x squared minus, and so y times sine xy, there's that piece, and then minus sine xy times x dy dx, there's that piece. Now I have it out of the parentheses, and now I can start trying to rearrange things and get dy dx. So the next step is to bring this whole disgusting term over to the left-hand side to join this one, because we need those dy dx's on the same side. So I did that. I just added this piece to the left-hand side, and that's where we are right here. 3y squared dy dx plus x dy dx times the sine of xy is equal to 3x squared minus y times the sine of xy. Whew, this one is a lot. But here's the good news. Now that they're on the same side, I can factor them out because they're in both terms. Admittedly, the terms are huge and disgusting, but I factored it out. So I factor it out, and now I just have 3y squared plus x sine of xy equal to that mess. And then to finish it off, I just divide both sides. There you go. That one's a big, ugly disaster. If you can find your way through that one, you're probably going to be just fine with implicit differentiation. So I've got more because we're not done yet. So hang on for the next board. All right, so now we're going to talk about tangents and normal lines. A normal line is perpendicular to the tangent line. So if you can find a tangent line, you can find a normal line by using the fact that perpendicular lines have slopes that are opposite reciprocals. So for instance, if you found the tangent line and it had a slope of positive 3/2, the normal line through that same point would have a slope of negative 2/3, right? Flip the fraction over, change its sign. Now I'm told that this comes into play with lenses, like bending light, which is maybe of special interest to those of you who wear either glasses or contact lenses. So anyway, so we're going to do an example on the next board. Let me get it up on the board. All right, so let's look at this example. For the curve x cubed plus y cubed minus 9xy is equal to 0, find the tangent and normal lines at the point 2, 4. So on this board, we're going to do all the work to get the derivative taken care of, and then on the next board, we'll worry about the tangent and normal lines, which are really pretty easy once we have the derivative taken. So here we go. Here's the mess. I need to take the derivative with respect to x of both sides. The good news is, on the right-hand side, the derivative of 0 is just 0. On the left-hand side, we have a little bit of a mess. The derivative for x cubed is just 3x squared. For y cubed, it's 3y squared, but again, you can't forget that chain rule. Because we had a y that we just were working with, we get a dy dx. And then I have a minus sign with some parentheses here because 9xy is a product rule. Okay, so we're going to have to take that derivative. So the 9 is going to be in both parts. I could have probably left that out front too, but anyway, the derivative of x is just 1. So the first part is 9y, right? Derivative of the first part times the second, plus the first part, the x times the derivative of y, which is just dy dx. So that's a mess, and then I got rid of the parentheses, I pulled the negative through, so I get 3x squared plus 3y squared dy dx minus 9y minus 9x dy dx is equal to 0. Big mess, right? I can tell you're all thrilled. So, all right, where am I? All right, yeah, right there. Now, I've got all the dy dx's on one side. I'm going to move everything that isn't dy dx to the other side so that when I do my factoring, I can go ahead and finish this up. So I add 9y and I subtract 3x squared. So I wrote it as 9y minus 3x squared. You can have that turned around and that would be okay. Then I factored out the dy dx, and then so giving me dy dx times 3y squared minus 9x, and then I divided both sides to get my answer. 9y minus 3x squared all over 3y squared minus 9x. Sadly, that's not my answer. I still need to know the tangent and normal lines at this point. So that's what we're going to do next. So hang on, and I'll be right back. All right, so we're continuing on with our problem to try and find the tangent and normal lines. We have the derivative. You can see I wrote it down here at the bottom of the screen. And now we just need to actually find the two lines. So to do that, I'm going to start with the tangent line because we know that this will give us the slope of the tangent line if I just plug in the 2 and the 4. So I did that. I plugged in 2 and 4 for all the y's and x's. As you can see, it works out to be 24 over 30, and that reduces down to 4/5. So at that point, since I have a point and I have a slope, I can write the equation of the tangent line in point slope form. It's just y minus 4 is equal to 4/5 times x minus 2. The normal line is even easier. We don't have to do anything really to get to it, except we do have to just change the slope. We flip it over, make it 5 over 4, and we change it to a negative. And its equation then is y minus 4 is equal to negative 5 over 4 times x minus 2. There we go, tangent and normal lines, very fun. All right, so I have a little bit more, but I am going to put them on, it's not a lot. You're going to get a second video, but it's going to be really probably quite short. So thanks.